Hello, I welcome you all to this another interesting screencast. The problem reads the mine car and its contents have a total mass of 6 megagrams and a center of gravity g. If the coefficient of static friction between the wheels and the tracks is mu s equal to zero point 0.4, when the wheels are locked, find the normal force acting on the front wheels at B and the rear wheels at A when the brakes at both A and B are locked. Does the car move? Alright, this particular problem is coming from the Engineering Mechanics Statics textbook, 13th edition by R.C. Hibbeler. So first things first, draw the free body diagram. So we have the weight acting through the center of gravity G. Okay, they are like so. And then we have the reaction, the normal force, like so, and also there the normal force. Then we have friction. Okay, friction is it always resists the movement of two contacting surfaces that move or slide relative to each other. So this direction cannot change as long as the force is in that direction shown. Alright, so let's label this. Let me also indicate this length here. I indicate this length here. So this one becomes a 0 point. This is 0.9, right? This is, let's call this as FB. This is NB. This is NA. And this is FA. And this one is W. Alright. So how many unknowns do we have? So number of unknowns. We have 1, 2, 1, 2, 3, 4. There are 4. And then of course number of equations of equilibrium, we have 3. Alright. Of course what they're asking us to find are the normal force, which we can still find with the available equations of equilibrium. But let's say we want to find all the forces. Let's make one of these particular forces. So let's assume Fa equal to mu mu s by Na, which is just equal to 0.4 Na. Alright, let's find these normal forces. So what I will do is, let's take moments about point B. So we'll say summation of moments about point B equal to 0, and clockwise being our reference. What do we have? We have a minus W by 0.6. Okay, and then we have a plus Na by 1.5, and then we have a plus 10 by 0.9 plus the radius of the wheel, which is 0.15, equal to 0. Our W is equal to our W is going to be equal to this is mega, so say 6,000 kgs by 9.81. Okay, 9.81. So what does this one give us? That's 6,000 by 9.81. So this gives us a 58,860 newtons, which is also equal to a 58.86 kilonewtons. Therefore, our NA is just going to be equal to, what is the value of NA here? Let's calculate minus 58.86 by 0.6 plus 10 by 0.9 plus 0.15 divided by 1.5. Of course, this gives us a 16.544 kilonewtons. So 10 by 0.9 plus 0.15 minus 58.86 by 0.6 divided by 1.5, 16.544. Alright, so found this. So let's use this other equation to find the vertical component. So this is just going to be equal to NB plus NA minus W equal to 0. And we know that W is just equal to a 58.86 kilonewtons. And our NA is equal to, we calculated NA already, is going to be equal to 16.544 kilonewtons. Therefore, NB is just going to be equal to, so we have minus 58.86 plus 16.544. So NB is just going to be equal to 42. That's 42 point 42.316 kilonewtons. Alright. Then there is a follow-up question to say, does the wheel move? Right. So let's use numbers to answer that question. We have this 10 kilonewtons. This is the one that should cause the wheels to move. And this particular 10 kilonewton should overcome these friction forces, right? So let's calculate them. We did say that we assumed that let FA be equal to 0.4 NA. And then we know that our NA, we calculated NA already is 16.544 kilonewtons. Therefore, our FA will just be equal to, as 0.4 by 16.544. So this gives us a 6 point. Okay. FA is just going to be equal to 6.61. Of course, you can round off this to just 2 decimal places. You don't have to do this. 66176 kilonewtons. Okay, right. So we have, let's apply one equation of equilibrium, summation of forces in the x direction. So we have minus 10 plus FB minus A plus FA equal to 0. We already know what FA is equal to 6.6176 kilonewtons. Therefore, FA, FB, FB is equal to, FB will be equal to, that's minus 10 plus 6.6176. So this gives us a 3.3824 kilonewtons. All right, and we know that what's the maximum at B? The maximum at B, FB max is equal to mu s NB, which is equal to 0.4 NB, and we know our NB is equal to 42.316. Right, so that's the value of our NB there. Okay, so therefore FB max is just going to be equal to 0.4 by 42.316. So this gives us a 16.9264 kilonewtons. Of course, we know that FB equal to 3.38 kilonewtons is by far less than FB max, okay, which is equal to 16.63 kilonewtons. Of course, there we have no slip. All right, but if you remember, we had assumed FA equal to 16.5, I mean 6.61. So we are saying the car won't move. All right. The car won't move because therefore we are saying the car will not move so the main car will not move. Okay, it will not move because for car to move we still have room at B. Okay, of course at A, for car to move we need both of them to move, right? So we said FA is equal to FA max, which we calculated as equal to 6.62. All right, FB is equal to 3.38 38 kilonewtons and is less than FB max, okay, which is equal to 16.93 kilonewtons. All right, so this one is impending, this is impending, that one is impending motion, then this one is no motion, no impending motion, okay, no impending motion. All right, therefore the car won't move. Okay, we don't expect, because we still have room. You've seen here we still have room, so this car is going to be in equilibrium at the values we've calculated. Fa equal to 6.62, which is the maximum, and FB equal to 3.38, which is less than the maximum. Okay, so it means this 10 kilonewtons, we can keep on increasing it until FB reaches the maximum, and when we exceed the maximum, that's when you expect both will begin to move. At this particular point, FA, or the wheel at A, is at just a verge. Okay, it is at the verge of moving or impending motion, but we still have a lot of force that is required at B. All right, like we've seen here, for it to move. All right, so let's just outline our final solutions. Of course, this normal force, we have NA there, we have NA like so, and then we have NB, and then we have this other condition that we are just trying to explain, to say there is not going to be any movement. Right, I hope this video was helpful, and if it was, give me a thumbs up. I like my video, continue subscribing and liking my channel. Bye bye, and see you in my next screencast.